Chapter 3-1, solving systems of equations. This is a new chapter. And with the new chapter, what our whole point of today is to be able to take two equations in the form of y equals mx, or they're not in the form of y equals mx, so you need to get them in that form, and find in space where they cross. See that? This could be an example of where two lines in space cross. What do you notice about these two things? Two lines. This side is their yard. Their slope is what? Their slope can't be the same, right? Doesn't matter where I move the yardstick, right? They can both have positive slopes, they can both have negative slopes. Okay? The point is they're going to cross out in space. Okay? That's one example. Another example is whenever they cross in more than one spot because they are exactly the same lines. Therefore, they have infinitely many points in common. Do we see that? Yes. Yes? Another example is whenever they have absolutely no points in common out in space, and what type of lines do those? Parallel lines. Parallel lines have exactly the same slope, different y-intercept, but they do not ever cross in space. Do we understand that? Okay. Now, we have four methods: graphing, linear combination, substitution, and determinants. We're going to learn all four. What you need to know is that graphically is the absolute worst way to find your point of intersection if you're expecting it. Why? Because our eyes cannot see anything past a half unit. If we say something is below a half, we generally say, oh, it's about a fourth. Well, it could be a third, right? It could be a fifth, but we can't see that. So graphing by hand is generally our worst option. So what we have a tendency to do is to do everything on the graphing calculator where there's the most accuracy that we have. Do we all understand that? Now, this is the meat and the potatoes of this section. And this talks about our possible intersection points. Now, if the system is consistent, that means that there is a point of intersection out there. There is a point, or there are many points in common. Now, if you are a consistent system, again, you have a point of intersection. There are two types: independent versus dependent. Independent means that you have one solution, meaning that you can actually see the one point of intersection out there in space. Do we understand that? Okay? Dependent means that you have many points of intersection. The difference between these two is the slope is different if you are a one point of intersection. If you have many points of intersection, that means that the points that are common are all of them because the slopes are exactly the same and the y-intercepts are the same. Okay? Now, look at these two equations. 2x plus 5y is equal to -3, and 6x plus 15y is equal to -9. What can you tell me about those two equations? I'm sorry? The bottom equation is a multiple of the top equation is a multiple of 3. Yes? This is what I consider this to be. Whenever you go to homecoming, prom, dress up for anything, right? You do not look the same as what you look today in your class. Your hair is done differently. If you're a girl, you are dressed differently, you have makeup on, there's all kinds of things going on that are different about you. If you're a gentleman, you probably got a haircut that day and you made sure that your hair looks appropriate instead of just getting out of bed and coming to school. Yes? The thing about it is are you changing your DNA? Are you still exactly the same person? Yes, you are still exactly the same person, which means the DNA of the equation is the slope and the y-intercept. If you're comparing two equations and they have exactly the same slope and exactly the same y-intercept, that means they are exactly the same equation. So therefore, every point that they have in common is going to be a point of intersection. Do we understand that? Now, how do we denote that? The way we're going to denote that is by saying that the slope and the y-intercept are the same, and that we have infinitely many solutions. And we're going to say x comma y. What does that x comma y mean? It means every ordered pair. It means every ordered pair. The colon means such that 2x plus 5y is equal to -3. What I've done is I've put down the equation that I want to pull the ordered pairs from. Do we understand that? I've written down the equation that I choose to take the ordered pairs from. Does it matter which equation I choose? If they're both the same, does it matter? No. One's a multiple of the other. They're still exactly the same DNA, the same slope, the same y-intercept. Do we understand that? Now, the next type of system we're going to have is called an independent system. Sorry, inconsistent system. And this is where you have absolutely no point of intersection. The reason why you have no points of intersection is because the lines are parallel. Well, what we talked about previously is that if the lines are parallel, that means that they have exactly the same slope, but they have a different y-intercept. You understand that? Which means they're never ever going to touch out in space. You with me? This page is the important page. This page is the important page. This is what I want you guys to have open while you're doing your homework. Okay? This is the page I need you to memorize. And it's comparing your slope. Okay? If your slope is different on your two equations, then that automatically means that you have a consistent system, it's independent, and I have one POI. What's POI stand for? POI stands for point of intersection. So if my slope is different, I automatically am consistent, independent, and one POI. You with me? Now, if my slopes are the same, then I can branch off into two cases. My first case that it could be is I'm going to compare my y-intercepts and say, is my y-intercept the same or different? If my y-intercepts are the same, that means my slope's the same, the y-intercept's the same, that means that it is the same equation, right? Which means it's consistent, but instead of independent, now it's dependent, and I have not one point of intersection, but many points of intersection. Do we understand this? Now, if my slopes are the same, but they have different y-intercepts, that means my slope is that my lines are parallel, and that it's inconsistent with no solution. Okay, so again, this page is crucial. Now, what have I been talking about the entire time that we've been doing consistent and inconsistent so far? POIs are end game plans, right? So what have I been comparing the whole time? My y-intercept and my slope. I'm comparing my y-intercept and my slope, which means, wouldn't it make sense that every one of my equations that I have, I'm giving you something that looks like this. You see that? Are they in slope-intercept form? No. So what do I have to do to get them in slope-intercept form? I have to solve for what? Solve for y. Because our game plan is to go ahead and to predict our POI by using the lovely little graphic calculator. Now, I skipped a page here, and I did this because we're going to be doing this all together here in a minute. And these are the steps to find the intersection point graphically on the graphic calculator. Okay? And you guys know how to do that. It's not going to be that big of a deal. We'll walk through them together here in a little bit. But basically, it's solve each equation with y, find each slope and y-intercept on your graphic calculator, open a new document, choose graphs, type the first function, hit the tab key, type the second function, click menu, analyze graph, intersection point, lower bound, enter, right down, enter, and then it gives you your POI. And we'll do all that here in a second. So here we go. I give you the two equations. So step one, what do I want to do? I need to solve each of them for y. So the way I'm going to do that is I'm going to have negative 3x plus 2y is equal to 8. And I'm going to have x plus 2y is equal to negative 8. So what do I do to the first red equation on the left? I'm solving for what letter here? I'm solving for y, so what do I do? I'm going to add 3x to both sides. So I have 2y is equal to 3x plus 8. Then what? I'm going to divide each term by 2. So I have y is equal to 3 over 2x plus 4. Now from here, tell me, what is my slope? 3 over 2. And what is my y-intercept in ordered pair format, please? 0, 4. Very good. Now, I need to take my second equation. I need to do exactly the same thing. Why am I doing this? Because I need to compare my slopes to my y-intercepts. Do we understand that? So what do I do to solve my blue equation? Subtract x. 2y is equal to negative x minus 8. Now what? Divide each term by 2. Why am I dividing each term? So my slope falls out to give me negative 1/2 x minus 4. So now what is my slope here? Negative 1/2. And what is my y-intercept? 0, negative 4. Now remember, I told you that we're going to be comparing our slopes first. If we cannot come up with what we are comparing our slopes, then we have to compare our what next? Our y-intercept. So I'm going to go back to the page that I found was so important. And I asked you, were my slopes the same or different? My slopes were different. So therefore, if my slopes are different, what am I? I'm consistent, meaning they intersect. I'm independent, meaning there is one point of intersection. Do we understand that? So let's go back to that page. I'm going to go ahead and write that down. I am consistent. I am independent. And I have one POI. Now, how do I find that point of intersection? The way we're going to find that point of intersection is going to our graphing calculator. We're going to open up a new document. And that new document is going to be a graphs page. Now, can anybody tell me what the first function was after we solved for y? What was that? 3 divided by 2x, correct? Plus 4. Okay, graph, there's my first function. Now, what's my next function? We're going to go ahead and hit tab, 2 keys down from escape. And there's my function entry line. And what am I going to type in there? -1/2 x minus 4. Hit enter, and there's my second function. Now, do you see where those two functions cross in space? Now, we are going to calculate the point of intersection by hitting menu. Then what? Analyze graph, and what do I want out of there? Intersection. Now, as soon as you click on intersection, it's going to immediately give you that vertical line, and it's going to ask for your lower bound. So you're going to go all the way to the left of the intersection point and click. Then it changes the lower bound to the upper bound, and then you're going to go to the right of the intersection. Do you see that shaded region? You're telling it that you wanted to find the intersection point in that shaded region, and hit enter. And now, what is my POI? What is my POI? -4, -2. So I'm going to go ahead and come back over here. I'm going to write my POI to be -4, -2. This is exactly what I want off of your homework tonight. Every single step, everything that I've boxed in there. Okay? You cannot do it unless you have this information right here. Do we understand that? Those two boxes are essential to have. Let's do this again. So what do I do, folks? I'm going to take the first equation, which is going to be 2x plus 4y is equal to 12. I'm going to solve that for y, so what do I do? Subtract 2x. 4y is equal to -2x plus 12. Now what? Divide each term by 4. Y is equal to -1/2 x plus 3. What is my slope? -1/2. What is my y-intercept? Is 0, 3. Good job. Now I need to come up here and I need to do the next one. That one is going to be x plus y is equal to 2. So what am I going to do? Subtract x. Y is equal to -x plus 2. What's my slope? -1. What's my y-intercept? 0, 2. Now, I'm comparing my slopes. Are they the same or different? Are my slopes the same or are they different? They're different. So what does that say about my type of system? It's going to be consistent, independent, and I'm going to have one POI. So if I'm going to have one POI, now what do? I need to go find that POI, correct? So I go back to my graphing calculator. I'm going to hit Control, Doc, and add a new graphs page. Anybody tell me what the function was I need to put in there? What was y equals x plus b? -1/2 x. What was it? Plus 3. Hit enter. Hit tab. Now what's the second one? -x plus 2. Was that it? And hit enter. Now how do I find my POI? Menu. Analyze graph. Intersection. Lower bound pops up. Now I'm going to go to the left of the intersection point. Click. Go to the right of the intersection point. Click. And what's my POI? Negative 2, 4. Do we understand that one, yay or nay?
Yeah.
We good? Okay, this one right here. Same exact thing. Let's solve for y. 3 is equal to 4y plus x. I'm going to subtract x from both sides. So negative x plus 3 is equal to 4y. Now what do I do with 4? Divide each term by 4. And I have negative 1/4 x plus 3/4 is equal to y. What's my slope? Negative 1/4. What is my y-intercept?
3/4.
0 3/4. Good. Go to the next equation. 4y is equal to negative x plus 3. So what do I do there? Y is equal to negative 1/4 x plus 3/4. What do you notice about these two things? They're both exactly the same. So what do I need to know here? Since they're both exactly the same,
You need to know the y intersection.
is my system consistent or inconsistent if they're exactly the same? It's consistent. Is it independent or dependent? It's going to be dependent. And how many POIs do I have? I have infinitely many POIs. And how do I write that? This is whenever you have the brace bracket over there. Put x comma y as ordered pair. And put the colon for such that. And does it matter which equation I choose? Nope, it doesn't matter which equation I choose. So I come up here, I'm going to grab the first one I see, which is 4y is equal to negative x plus 3. And you're done. We good? Okay, last one I'm going to do with you. And then I'm setting you guys free here. Okay, I need to solve this each for y, correct? So I'm going to have 4y minus 2x is equal to 6. Add the 2x. 4y is equal to 2x plus 6. Divide each term by 4. Y is equal to 1/2 x plus 3/2. What's my slope? My slope is going to be 1/2. And my y-intercept?
0,
0, 3/2. That's all gorgeous. Now let's go to the next one. 8y is equal to 4x minus 12. What do I do here? Divide each term by 8. Y is equal to 1/2 x minus 3/2. Now what do you notice about these two things? My slope is 1/2 over here. Now what's my y-intercept over here? 0, negative 3/2. Is everything exactly the same?
No.
No. The slope is the same, but what's different? Can you tell me what that means? So my slopes are the same, but my y-intercepts are different. No solution because the lines are going to be parallel. So that means the system is inconsistent. The reason why it's inconsistent is because they are never going to cross out in space. Why are they never going to cross? Because they are parallel lines. Done. Do I have to graph this? Nope, because I can see right away that I'm not going to have a point of intersection. Do we understand that? Excellent. I'm going to skip the next remaining few examples here. I'm going to give you your homework. Your homework is 17 through 28 all. Solve all problems for y. I need you to make sure you do that. Everybody write that down. 17 through 28 all for tonight's homework. How many of you brought your books? Yeah. Everybody got 17 through 28 written down? Give us 7. One moment, please. 17 through 28 all. Solve all of them for y. I want consistent, inconsistent POIs. You're not going to have enough time to be able to find your POIs graphically today on the calculator, and I know you need the calculator, so you need to make sure everything is done tonight. And I will give you 10 minutes or 7 minutes tomorrow in class to enter them in the graphing calculator and find the POIs. Deal? You have 12 problems. Any questions over anything I just talked about? Everybody got it? Okay, there are the problems from your book that you owe me for tomorrow.